Hello and welcome to this R tutorial. So in this tutorial we are going to apply PCA, and actually I've prepared you the required package to apply this first dimensionality reduction technique, principal component analysis. So these packages are Caret, which I think we already installed, but if that's not the case, then you can check it here in packages. You can see if you have Caret available in this list of packages. If you don't see it here, you can execute this line without a comment, and this will install Caret. So that's the first package. Then this is to actually import this Caret package, so we'll execute that as well. And we also need this other package that we installed in part 3, classification, the E1071 package. So normally you should have it installed, but if that's not the case, you can select this line and install the package. And don't forget to execute this line as well to select it. And now we are ready to start applying PCA. So the first thing that we're going to do is create a new variable that we're going to call PCA that we will use afterwards to transform our original dataset composed of our 13 features into this new dataset with the new extracted features. So now to create this subject, we're going to use a function. This is the pre-process function. Here it is from the Caret package. And let's now press F1 here to see all the info of this pre-process function. Because you're going to see that you have some very useful parameters that allow you to apply PCA according to your goals. For example, you can specify the minimum ratio of explained variance you want to get. That means, for example, if you want to reduce the dimensionality of your dataset down to a number of features that will explain at least 60% of the variance, well, you can specify this with one of the parameters of this preprocess function. So let's have a look at the info. That's the info, and let's jump to the arguments. So alright, the first argument is X, a matrix or a data frame. This is actually the data of which we want to reduce the dimensionality. So this is going to be our training set. So X will be the training set. Then the next argument is method. So method is your dimensionality reduction technique. So as you can see, you have several techniques of dimensionality reduction, PCA, ICA, so these are other methods, but of course the one that we want to use is PCA, principal component analysis. So we will use method equals PCA here. Then thresh. Thresh is a very important parameter. That's what I've just told you. If you want to reduce your dimensionality of your dataset with at least a minimum amount of explained variance, well, you can do it by using this thresh parameter. And as you can see, it's a cutoff of the cumulative percent of variance to be retained by PCA. So for example, if you want your new extracted features to explain at least 60% of the variance, well, you need to specify here thresh equals 0.6, 60%. But we're not going to use this thresh parameter here because we already know what we want. What we want is two independent variables because we want to be able to visualize the training set results and the test set results. And that we will be able to get with the next parameter, PCA comp, that is the specific number of PCA components to keep. So that's exactly the number of extracted features you want to obtain in the end. So here we will input PCA comp equals 2. So that our training set, our original training set, will go from having 13 independent variables, the 13 original independent variables that we had in our dataset, to having 2 new extracted features that will explain the most the variance. And as you can see, if we specify this PCA comp parameter, this overrides thresh, so that's why we don't need to specify this thresh parameter to specify a minimum cumulative percent of explained variance. Alright, and then you have other parameters, but we won't use them. We actually only need our X to specify the data we want to transform to extract the new features, the method, PCA, and the number of extracted features we want to get eventually. That is 2 new extracted features. So let's input the arguments. Let's start with the first one, X equals, so that's training set. Here we go. And actually we need to specify the features. And actually that's not the whole training set because Remember, PCA is an unsupervised dimensionality reduction technique. That means that we don't consider the dependent variable to extract the new features. So we actually need to remove here the dependent variable. And remember, this has index 14. So the way we can do that is the same as we did for feature scaling. That means we just add here minus 14. All right, so now PCA will be applied on all the features, the 13 features of our training set. Perfect. Now next argument. Next argument is method. And as we said, method equals, in quotes, PCA. All right, then comma, next argument and last argument. And as we said, that's PCA comp. So PCA. And what we want is 2 new extracted features. All right, so that creates the PCA object that we will then use on our training set to transform our original training set composed of our 13 independent variables to this new training set of reduced dimensionality, and that will contain the 2 new extracted features that will explain the most the variance. So let's do it. Let's take our training set, because we're going to call this new training set as well, because then we have all our templates and we use this training set variable name. So we want to keep this training set name. But of course, if you want to keep your original training set and test set, you can use other names like training set underscore PCA. But then if you do that, don't forget to change training set here by training set PCA, and here test set PCA as well. And same for the confusion matrix section, and especially here, visualizing the training set result, you will need to replace training set here by training set PCA. All right, so that's why we're keeping the name. It's in order not to have to change everything. So let's go back to training set equals, and now let's transform this original training set into our new training set composed of our new extracted features. And to do this, it's very simple. We use the predict function, and inside we take our PCA object, comma, and we apply this PCA transformation object on the original training set that is named training set as well. And so by doing this, this original training set will become this new training set composed of the 2 new extracted features. So let's do it. Let's start by creating this object, and then we will transform our training set. So I'm going to select this line and execute. Perfect. The PCA object is ready to be used on the original training set to transform it into our new training set composed of the 2 new extracted features. So let's execute this as well. Here we go. Our new training set is now created. We can have a look. As you can see when I'm clicking on this, well, I have a new training set composed of 2 new extracted features. And remember, these 2 new extracted features are called the principal components. So that's where you have PC1 and PC2. And of course, we still have our dependent variable vector, the customer segment dependent variable with its 3 labels, 1, 2, and 3. All right, perfect. But now, as you can clearly notice, the dependent variable vector just went in first position. And since then, we're going to use a template on data sets, I mean the training set and the test set, where the dependent variable is in last position. We will need to put this dependent variable in last position here. And that's actually very easy. What we only need to do is play with the indexes to put this customer segment dependent variable in last position. So the method is really easy. We're going to take our training set again. Here we go. And then equals. And then we take again our training set. Then brackets. And then inside these brackets, we're going to take the indexes of the columns of our training set in the correct order we want to get. So you're going to understand that now. We're going to take a vector. So remember, in our vector, it's taken with C and then parentheses. All right, and inside these parentheses, we put the correct order of the indexes we want to get. So let's go back to our training set. The first column we want to get is PC1. That should be the first column of our new training set. And this has index 2. So here we input the first index, which is 2. Then comma, and then we input the second index we want to get, that is the second column, and the second column is PC2, and this has index 3. So here we input 3, and then here you input the index of the last column you want to have in your training set, and the last column you want to have in your training set is this customer segment column, because that's the dependent variable, and so far this customer segment has index 1. So you need to specify here this index that is 1. And by doing this, our new training set here will be the same training set that we have here, but with a new order of the columns, and that is given by this order here. First, the first independent variable that has index 2, then the second independent variable that has index 3, and eventually the dependent variable column that has index 1. You're going to see, if I select this line now and execute, and if I go back to training set, now I have my first 2 columns as the new extracted features, PC1 and PC2, and the last column, customer segment, in last position, as our code templates that we're going to use is expecting it. So that's perfect. We can go back to PCA, and now we need to do the same for the test set. So what we're going to do is select these 2 lines, copy them, and just replace training set here by test set. Same here, test set, and same here as well, test set, and eventually test set. All right. And that's of course the same indexes for the order you want to have. We can check it out. I'm going to select this line. As you can see so far, the test set has its 13 original features. Then if I execute this line, it now has 2 new extracted features, the principal components 1 and 2. But the customer segment is in first position. We want to put it in the last position. And so to do this, we execute this line, and that will do it. If I go back to test set, now the customer segment is in last position, and we are ready to use the following parts of the template: predict the test set results, make the confusion matrix, and eventually, that's the most exciting part, we will now be able to visualize the training set results because we now have 2 dimensions in our training set and test sets. So I look forward to visualizing these results in the next tutorial, and until then,